Okay, leaving off, we left off in the middle of problem 2. I'm going to continue. So I figured out that a was 4. I'm coming over to the original function. I'm going to plug in x equals 2 and a equals 4, and we'll be able to solve for b. So 2 times 4 times 2 squared plus b. And that equals 5. That's the point on the curve, right? So 16 minus 2 times 2 is 4 times 4 is 16 minus 32 plus b equals 5. Negative 16 plus, b equals 5. I'm going to add 16 to both sides. B equals 21. So this function turns out to be x to the 4th minus a 2a, so 8x squared plus b plus 21. And I actually went and looked at this graph to see that it worked. It seemed to work when I graphed it. So now it says let's find the inflection points. Well, now that I have the a's and b's filled in, the first derivative looks like this. 4x to the 3rd minus 16x. And now I can take the second derivative, which is 12x squared minus 16. So if I set this equal to the 0, I can find the inflection points. So I'll add 16 to both sides. X squared equals 16 over 12, which is 4 over 3. If I take the square root, I get positive and negative 4/3, which is positive and negative 2 over the square root of 3. I'm going to rationalize. So my points of inflection are positive and negative square root of 3 over 3. Those are the points of inflection. Alright? Alright. Moving on to number 3. Oops, I had a double one if I needed it. The average of two non-negative numbers is 180. What's the largest possible product? So, average, that means that two numbers I want to call them x plus y divided by 2 equals 180. And the product would be x times y. But I need to get this in terms of one variable. So I'll say x plus y, if I multiply by 2 on both sides, equals 360. So y equals 360 minus x. So I will plug that in for y over here. So p equals 360x minus x squared. So let's take the first derivative and set it equal to 0. All right, so there's that, set it equal to 0. 360 equals 2x, divide by 2, x equals 180. Well, guess what? If x equals 180, y equals 180. And to maximize what is the largest possible product, right? It's going to be x times y, 180 times 180, which is 32,400. That's the largest possible product. All right, calculate each limit, or compute each limit. So here, we're going to have to use L'Hopital's rule, right? Because these are indeterminate. If I actually just substituted in 0, I'd have a 0 on the bottom. I'd have 1 minus 0. So that's indeterminate, right? So I need to take the derivative. Okay, the derivative of the top is t, e to the t. This one goes away. Minus 1 over 2t. Well, this would be 0 minus 1 over 0. Really indeterminate again. I can't have a 0 in my denominator. Take the derivative again. So here I have a product rule. The derivative of t is 1 times e to the t plus t times the derivative of e to the t, which is e to the t times t, so that's really t squared, over 2. So this is what we get. If we're looking now at the limit as t goes to 0, this term goes to 0, this term is 1 over 2. That's not indeterminate. This gives us our limit for that first, for a.